All right, time to start. Today, we have just one topic, that's climate change. But I want to remind you that our next class meeting on Monday, we'll have a class discussion. And I've given you an assignment to submit any questions you have. And that is due on Saturday, December 4th. And then I will compile your questions and have them ready for discussion on Monday. So anything in the entire course, because this is going to be a review for both test 3, which will be a week from today, and the final exam, which will be a week after that.
I have a question.
Uh-huh.
Do you know if the final will be also 1 hour or like 75 minutes or 2 hour long?
It will be 2 hours, 2 class periods, so 150 minutes. And you'll have 2 attempts, and it will cover everything that we've covered in the course. And it'd be the same type of questions that you've been having all along. So the study for it just the way you've been studying for all the other quizzes and tests.
I have a quick question, Professor.
Yeah.
Remember how you said we get extra credit if we like talk in the class? When
Uh-huh.
will that be put in?
That's added in at the end.
Oh, okay. So it's not already added in right now?
No.
Okay. That's all I really needed to know. Thank you.
Yeah, okay. Yeah, I'm going to send out that spreadsheet sometime soon. I think I'll send it out next week, and make sure that you check it carefully. And make sure that I haven't missed participations that you've made. And it is important because it can significantly affect your final grade. So,
Esther, this is Alicia Carroll, or
uh-huh.
Alicia Anderley, sorry. I remember you saying that you were going to drop our lowest quiz score. Are you still going to do that? And if so, when would that reflect on our grade?
Yes, I will drop your lowest quiz score. And it may or may not affect your final grade. And the reason is that the quizzes are only worth 10 points. But if you're on the line between 2 grades, then dropping the lowest quiz score might affect that.
Thank you.
Okay, anything else? All right, I want to share my screen with you.
I have another question.
Okay.
There will be like a study guide for the final test.
Say that again.
There will be a study guide for the final test.
The study guides have been cumulative as we've gone along. So most of the slide sets have at the end of them a list of points about that topic. So you can regard that as a study guide. Go over those points and make sure you understand them. The other thing that should guide your studying is the past tests and quizzes. I won't ask the same identical question again, but what you see on the past tests is the topics that I consider important and that I think you should know about. So if you familiarize yourself with what's gone on in the past, it'll help you prepare for these upcoming tests.
Okay, thank you.
Professor,
Uh-huh.
Oh, maybe you guys already asked this question, but I just got here. I just wanted to know how long is going to be the final?
It will be 2 class periods, so 150 minutes. And you'll have 2 attempts. All right, anything else before we start? Do you see climate change on your screen?
Yes, I can see it.
Yes.
Okay. And now it should cover your whole screen?
That's right.
Okay.
Yeah.
All right, going to talk about climate change, and I'm going to tell you the end right at the beginning. The take-home message here is, and I should say, I know that you're all familiar with climate change and global warming. And so my goal here is to focus on some of the high points and what I think are the major problems and what I think are the major solutions. So here are points to consider. Global warming is threatening life on this planet in general. And I'll elaborate a bit on how serious the threat is. The main cause of global warming is carbon dioxide in the atmosphere. Where does it come from? From burning things, combustion by humans. So the solution is simple enough. Stop burning things to generate power and instead generate power from non-combustible sources. So energy sources can be either burnable, combustible, which generates carbon dioxide, or they can be non-combustible. We're going to focus on those 2 things. So let's consider the carbon cycle on the planet. Carbon dioxide is produced primarily by respiration from both plants and animals. This is in an undisturbed environment. Carbon dioxide is consumed by photosynthesis. You remember when we talked about photosynthesis, the dark cycle of photosynthesis takes carbon dioxide out of the air and incorporates it into organic compounds. And these organic compounds then can enter the earth, and often they end up as deposits of what we call fossil fuels. Coal, gas, and oil are the main ones. So what has happened as a result of human activities is that we take up these fossil fuels and burn them, generating more carbon dioxide, and we burn and cut down our forests so that we have less photosynthesis going on, less consumption of carbon dioxide, and more production. And the result of this is increased carbon dioxide in the atmosphere, and that has led to global warming. So just a word about the chemistry of it. And I've got one example here, but this is applicable to any substance, any organic substance Organic means that if it has carbon in it and you burn it, that means you oxidize it. And that is essentially what this formula is showing. So I've taken an example, gasoline, which if you drive a car that still burns gasoline, it's mostly octane, a hydrocarbon, 8 carbons. And when you start your engine, 2 molecules of octane combine with 25 molecules of oxygen and result in the production of 18 molecules of water and 16 molecules of carbon dioxide plus energy. That's what makes your car go. So for every 2 carbons of octane, you get 16 molecules, I should say 2 molecules of octane, 16 molecules of carbon dioxide. And as I said, this is true for any organic material. Now, in addition to global warming, carbon dioxide contributes to depletion of the ozone layer in the atmosphere, acidification of the environment, toxicity to the environment, and even toxicity to humans. You've probably all heard of the greenhouse effect, and I want to make sure that you know what the greenhouse effect is. So when the sun shines, the light strikes the surface of our planet. Some of that light is absorbed as heat, some is used in photosynthesis, and some is reflected off the surface back out into space. What carbon dioxide and other gases, there are others in addition to carbon dioxide, what they do is form a layer in the atmosphere, in the upper atmosphere, which traps some of the sun's light, so that instead of reflecting back out into space, it gets trapped here, just like sunlight gets trapped in a greenhouse. And that causes the temperature to rise. Most of the gases responsible for this, the major component is carbon dioxide. 80% is carbon dioxide, 10% methane, and then there are some other gases that also contribute. But CO2 is the main one. And if you look at carbon dioxide over a long period of time, in this case, 800,000 years, it goes up and down, up and down, up and down, depending on other conditions on the planet, until you get close to present. And in recent years, it's gone exponential, completely out of sight. Now, this shows how global warming coincides with the increase in burning of fuels. Starting in 1880, just about the time of the Industrial Revolution starting. And you can see that it's gone up, the global temperature plotted on the y-axis has gone up starting with the Industrial Revolution. And this is just a reinforcement of that. If we look on the left, the temperature anomaly, so the baseline is the temperature average between 1951 and 1980. So before that time, temperatures were cooler than average. And since that time, much higher than average. Now on the right here is a simulation of what a computer model generates if there was no human activity. So instead of the temperature rising precipitously, it would have remained stable. I want to make a point about weather and climate. You've probably all heard from time to time someone saying, oh, it's really cold today. How can we be having global warming when it's so cold? Well, someone who says something like that is not distinguishing between weather and climate. The weather is the state of the atmosphere at a particular point in time, at a particular place. So it's very specific weather. And the factors that are included in weather are heat, humidity, sunshine, rain, wind, and so on. So a point in time and a particular place, the state of the atmosphere is weather. Climate, on the other hand, is weather averaged over a long period, usually 30 years. So you can't assess climate change or global warming by looking at weather. You have to look at climate and see what's happening over long periods of time, which is what you see in these graphs. This is just an interesting comparison of what's been happening in the US since 1900. Just look at the colors. Blue is cool, red is warm. And you can see that the map has changed since 1900 from mostly blue until, if we get to the present time, it's almost entirely red. In the western part of the US, very red. Global warming has a lot of effects listed here: rising sea levels, extinction of plants and animals is going on at a much higher. Remember, we talked about extinction, that it's a necessary part of evolution, but that's over long periods of time. Over short periods of time, extinction is not good because it destabilizes the complexity of ecosystems. So species of both plants and animals are becoming extinct at an alarmingly rapid rate. Plant and animal behavior is affected, human welfare. 1.5 million people die every year due to climate change related factors. As you probably know, storm frequency and storm intensity is increasing dramatically, as are droughts. In fact, here in the West, we're in the middle of a very serious drought, and there's no projection of any relief from that anytime soon. Economic collapse, ecosystem failure, and even wars arise as a result of global warming. I mentioned rising sea levels, and I thought this was interesting. A computer model here on the left of what would happen in North and Central America if all the ice on the planet melted. That is, the Arctic and Antarctic ice caps all melted. The projection is that starting on the East Coast, New York would be underwater, Norfolk, Virginia, Charleston would be underwater, the entire state of Florida would be underwater, along with the southern Gulf Coast, New Orleans, Houston, and even Pine Bluff, Arkansas. Cancun would disappear. And on the West Coast, the Bay, Baja California would become much larger, extend up even north of San Diego, and San Francisco would be just a cluster of islands. Hawaii would disappear except for parts of the Big Island. Now, already some entire nations, island countries in the South Pacific, are in danger of disappearing. Here you see an example of an atoll in the South Pacific before sea level rise and what it looks like now, completely covered with water. So here's a series of names of countries that are likely to disappear or at least be badly damaged, uninhabitable as a result of sea level rise alone. So now let's look at where we get our energy. 3 different types, from fossil fuels, renewable fuels that are combustible, and renewable fuels that are not combustible. So worldwide, about 75% of total energy comes from burning fossil fuels. They are non-renewable and they are combustible. About 15% comes from renewable fuels that you burn. So these would be things like ethanol from corn, biofuels, biomass, waste, but all of these things, you get energy from them. But to get that energy, you have to burn them. So they are, in principle at least, carbon neutral. That is, it takes carbon fixation to produce ethanol or biomass or biofuels, but then you have to burn them to get the energy out until you regenerate the carbon dioxide. In contrast to that, renewable fuels that are not combustible do not generate carbon dioxide, but this is only about 5% of the worldwide energy supply. And these sources would be water power, wind, solar power, geothermal, tidal power, and wave energy. And then there's an additional 5% that comes from nuclear generators. So the essential point here is that carbon dioxide accumulation will end only when the sources of it are eliminated. In other words, the main source now is fossil fuels, and we continue to burn them. I've got pictures here of various different types of non-combustible energy sources. The main ones that are a factor and will continue to be a greater factor in energy production are solar panels, wind turbines, hydroelectricity, that means dams on rivers, and nuclear power. I want to make a point here about contrasting fossil fuels with non-combustible energy sources. And this has to do with the first law of thermodynamics. If you remember, we talked about that earlier. Energy is neither created nor destroyed, it only changes form. So fossil fuels are one form of energy. Renewable sources are another form. Fossil fuels are energy that has already been concentrated. So where did they come from? They came from photosynthesis, carbon fixation, long ago, and they've been stored underground ever since this energy was concentrated. So the sun's energy through photosynthesis was concentrated into organic molecules, and it's sitting there. All you have to do is light a match and it burns. You have instant energy. So that's one form, and it's really handy because it's so readily accessible. Now contrast that to renewable energy, which is too diffuse to do work. So the wind blowing, you can't extract any energy from a breeze. You have to do something with it. And what you do in the case of wind is put a windmill there, which turns a turbine the turbine then generates electricity. And that is not convenient. So instead of having instant energy from wind, you have to concentrate the energy first. And the same thing is true of solar panels. We don't derive energy from the sun. Plants can do it, but we can't. And so what solar panels do, they generate heat, which can turn turbines to generate electricity. So the point here is that fossil fuels are very convenient. Energy is already concentrated and ready to use instantly. Non-renewable sources of energy are not. And so we need technologies to convert non-combustible energy sources into useful energy. And this is all because of the first law of thermodynamics. So let's look at how things are going around the world. And I'll just for comparison, I'm using Germany and the US. So net public electricity generation in Germany in 2020, last year, was 55% from non-combustible resources and 45% from combustible. And you can see they're plotted here in this circle. The non-combustible ones are nuclear power, uranium, solar, wind, and hydro, the blue. We can't include biomass because you burn it. And in addition to biomass, Germany burned fossil fuels, brown coal, hard coal, oil, and gas. The important point is that they got over half of their energy from non-combustible sources. Here I have data from the US energy consumption by energy source. It's not exactly comparable because this is from 2019, but you'll notice that the renewable energy is only 11% of the total. If you add nuclear energy to that, it comes to 19%. And the rest is all fossil fuels. But then if you take this renewable energy and break it down, we can see that only 57% of this 11% is non-combustible, and 43% is combustible. It's biomass, biofuels, or wood. So the total the total energy production in the US, only about 5%, in other words, half of 11, only about half, or about 5% came from non-combustible sources. So the US has a long way to go. Germany can be used as a model of how to get there. The US is making progress, but the question is progress being made fast enough? So an example, Norway races ahead with electric cars. So in 2019, 55% of the cars in Norway were electric. Whereas if you go down this list all the way to the bottom, in the US, only about 2% were electric. Now that was 2 years ago. The US has made rapid progress since then. And this is one of the hopeful signs going forward, is that the car production in the US is rapidly switching to electric. And in fact, just this year, Ford came out with an electric pickup truck. The F-150 model is the best-selling vehicle of any kind in the world, and it has been for 36 years. And this electric version was launched in May, of this year. It's all-wheel drive. It's got an extended gas motor for extended range, and it recharges batteries in case of emergency. But it's, from what I've read, it's quite a remarkable vehicle. In fact, President Biden visited a Ford plant and drove one of these just to advertise the utility of it. And you can see in this map of the US where the most electric cars are. And these are old data from 2017, but at that time, California by far, I think this is still true, California is by far ahead in electric vehicles, along with Hawaii. So looking forward, we have to focus. I think our two main hopes are wind power, showing that this wind farm, and solar power, these solar panels, and battery storage. So one of the problems, again, this goes back to the first law of thermodynamics, is that electrical power is ephemeral. That is, you produce it and you use it immediately. And if you don't, it has to be stored. And so storage capacity is one of the big problems we have. And a lot of effort, a lot of research is going on now, trying to figure out how to make batteries more efficient. And you can see that in terms of storage capacity, compared to 2014, the capacity for storage has gone up dramatically. For example, electric cars have to have batteries, and the batteries add a lot of weight. So the more efficient the battery, the more effective electric cars would be. Wind farms. The largest wind farm in the US to date was approved in May of this year. It's in the Atlantic Ocean, sort of between Martha's Vineyard and Nantucket, quite far out away from shore. And it's composed of these very large windmills. One turn of the blade generates enough electricity for one home for one day. And these stanchions are 300 feet tall, which means the blades are almost that long. So they're huge things and are remarkably efficient at generating electricity. So this is hopeful. This is the largest one to date, and more are coming along. Another hopeful development is called carbon capture and storage. So the whole idea here is that if you have industries that are producing carbon dioxide along with other materials, if you scrub the carbon dioxide out and store it underground, then what's left is free of carbon dioxide. On the right here, you can see just a comparison. An industrial facility without carbon capture, the carbon dioxide goes off in the air, and with carbon capture, it goes into the ground. There are examples of carbon capture facilities in various places around the world. The first one was started in 2014 in Canada. There's a picture of it here on the left. You can see that it's the carbon capture plant is this large facility here, and it's built right beside a plant that burns fossil fuels and generates carbon dioxide. And so this is a diagram of how that one works, but it's essentially like this, where the CO2 from smokestacks goes into a facility that takes the carbon dioxide out and stores it underground or in the water. So is this something that we can look for in the future? I think so. What I want you to look at in this graph is the light blue at the bottom. These are operating carbon capture facilities. So you can see that starting from between 2010 and 2020, every year, the number of operating carbon capture facilities has gone up. Another hopeful sign is what's called a carbon tax. The carbon tax would replace the personal income tax. So instead of being taxed on how much money you make, you would be taxed on your carbon footprint. Your carbon footprint is a measure of how much carbon you produce as a result of just being alive. Carbon taxes are already in place in various different parts of the country, parts of the world. I've got some of them listed here. And they've been in place for long enough to assess the utility of a carbon tax instead of an income tax. And listed here are some of the benefits: a drop in fuel consumption of all types, a decline in carbon dioxide emissions. It has no effect on economic growth, and it's revenue neutral. That is, it does not increase the total tax burden. It only increases one kind of tax, replaces one kind of tax with another, replaces the personal income tax with the carbon footprint tax. But what is a carbon footprint? Well, you can go online and look up a carbon calculator and calculate your own carbon footprint. But the definition of it is the amount of carbon emitted due to the consumption of fossil fuels by you or a group. So there are calculators online that you can use to calculate your own carbon footprint. And a carbon tax would be based on your carbon footprint and replace your personal income tax. So what has the international community been doing about this? There have been a whole series of international climate agreements. And the goal of all of them has been to limit global warming to less than 2 degrees centigrade relative to pre-industrial revolution temperature. So starting back in 1992, there was an Earth Summit in Rio de Janeiro. 2005, Kyoto, Japan. 2007, Bali. 2009, Copenhagen. 2010, a Cancun conference. Durban platform in 2014. And then in 2015, there was this big conference in Paris, which got a lot of attention. And there was a lot of hope that the Paris Agreement would result in significant change. So the Paris Agreement report card after 5 years. So after So this was done in 2020, 5 years after the agreement was made. The grade is D or F, depending on who's doing the grading. And this is based on the prospects of meeting the 2 degree centigrade target by 2050. So in a nutshell, the Paris Agreement has been a failure. There were some countries were promising to cut their net emissions to 0 by 2050. The names of those countries are listed here. The US pulled out of this agreement, but when Biden became president, he re-endorsed it. China is the world's largest source of emissions. In the Paris Agreement, it said it would aim for carbon neutrality by 2060. Russia and Brazil have rejected the Paris Agreement entirely. So what is the problem? The problem is that the ambitions are great, but there's little or no enforcement. So every country in the world promised to keep global temperature increases below 2 degrees centigrade by 2100. So that requires the cessation of fossil fuel burning, stop destroying forests, overhaul food production, and suck greenhouse gases out of the atmosphere with carbon capture. But each country is allowed to make its own plans on how to accomplish these goals. And every country is falling short because there are no penalties. And when tough decisions have to be made about policies, especially policies that affect economics, the easiest thing to do is continue to burn fossil fuels. Well, this year, in 2021, there was another international climate conference in Glasgow, Scotland, attended by over 100 countries. Here you see President Biden and the Prime Minister of Great Britain, Boris Johnson. There was a lot of demonstration, a lot of agitation for picking up the pace and making real commitments. And so what happened there? This meeting was called COP26. That stands for Conference of the Parties. It's the 26th one that there's been on climate change. And in the final agreement from COP26, 196 countries agreed to phase down burning of coal. Notice it's phase down and not phase out. And these same countries made a temperature goal of 1.8 to 2.1 degrees centigrade warming by 2050. One of the striking things, encouraging things about the conference was that the US and China agreed to collaborate on climate. And that's significant because they're competitors on the one hand, and on the other, they are the 2 largest polluters on the planet. There was a global methane pledge. 100 countries agreed to reduce their methane emissions by 30% by 2030. And you remember I said that CO2 was the biggest polluter in the atmosphere, but methane is second. So even though methane is small, it is significant. Regeneration of forests. This is the biggest carbon capture that we have, and we're destroying forests faster than we're regenerating them. So we're destroying the natural carbon capture. Over 100 countries, and these 100 countries contain 90% of the world's forests, committed to stop deforestation and in fact reverse it. In other words, plant trees. End of fossil fuel investment. 30 countries committed to the financing of fossil fuels as of 2022. 100 countries pledged to end the sale of cars with combustion motors by 2035. And there was a component involving indigenous peoples around the world. Developed countries promised to provide financial support to protect forests and local communities among people that don't have the financial resources to do this for themselves. Now, the same problem that I mentioned about the Paris agreement obtains here. There's no enforcement. There are no consequences for cheating. So the developed countries have pledged $100 billion a year for the next 4 years to fight global warming. What if they don't? There's no consequence if they don't. So the elimination of coal and the subsidies for fossil fuels was another point made by the conference. And the final version refers to a progressive reduction of subsidies for fossil fuels by governments around the world. Again, there's no enforcement.
Professor,
Yeah,
this is Alex. I just had like two quick questions. One regarding the assignment you put for like student questions to prepare for test 3 and final exam. Is that like everything that's gonna be covered for both those exams?
yeah. I'm hoping you can review all the material we've covered in the semester, and anything that you either don't understand or you'd like a deeper discussion of it, anything of particular interest to you, send those topics to me.
I see. And the last one was, when was the final exam? Is it the week after the test 3?
Yeah, test 3 is a week from today. The final exam is a week after that.
And that's it.
Yeah, that's the end of the course. So
Okay.
as far as us meeting, we're having a lecture today. We'll have a discussion on Monday, and that will be the last time we'll meet, because on Wednesday you have test 3 and we will not have a class period that day. You'll have all day to take the test. And then on December 15th, you will have all day on that day to take the final exam.
Thank you.
Okay, coming back to climate. I've just described all these conferences, international conferences, where promises are made, promises have not been kept so far. So where does that leave us? It leaves us that a solution to climate change will be driven by economics, not by politics. People respond to economics. You can't make politicians keep their promises. So international agreements are unenforceable, but energy from non-combustibles is becoming cheaper than from combustibles. And this is true in the case of solar power, wind power. It's becoming true with electric cars. Battery storage capacity is getting better and better. Carbon capture is not a major factor yet, but I think it will be. When you think of it, carbon capture is done by forests naturally, or humans can build machines to do the same thing. And carbon taxes. So far, carbon taxes have not gained much foothold. In some countries, they have a little bit, but the whole idea makes sense that you tax people based on the carbon they produce rather than on their income. Now, I still have a little time, and I thought you might be interested in a global perspective on climate change with respect to how countries interact with each other. The relationship of climate change to international relations. Well, this is based on a lecture that my son, Brandon, shown here, gave to one of my classes a couple of years ago. He is a professor of political science at the Australian National University in Canberra. His primary interest is US-China relations, but he gave a talk on the political implications of non-renewable energy, specifically fossil fuels. So the point he made was that dependence on fossil fuels promotes international conflict. And the market for fossil fuels promotes dictatorships. Then he proceeded to provide evidence for these statements. So oil exports support dictatorships and inequality. Oil production is easy for a government to control. It reduces the government's dependence on on its economy, because all it has to do is sell oil. And it allows the government to keep pro-democratic groups poor and weak. So the world economy is based on fossil fuels, period. So countries with oil-based economies, that is, they generate most of their income from oil, the government owns the wealth. So the allegiance of the government is to the global market for oil, not to the citizens of the country. And this fosters authoritarian regimes, and the citizens of the country suffer with no voice in policy. Now, in contrast, countries with diversified economies that are not based on oil, the wealth is owned broadly. The allegiance is to the people who choose representatives, and this fosters democracies. And I find this graph particularly interesting because it's a chart, it's a plot of governmental type plotted against democracy. Okay, so on the x-axis, you have plotted the percent of the government of the country's income based on oil. So 100% going down to 0%. And on the y-axis is plotted the democracy index. So what is the democracy index? Well, it's based on a complicated formula, but some of the major factors in that formula are whether or not there are free and fair elections, whether there is freedom of the press, whether civil rights are protected. And so this democracy index goes from 0 to 10, 0 being low, 10 being high. And so if you look at the countries that are plotted here, the oil producing countries are all down here at the lower left. they all have authoritarian governments with little democracy. And as you go to the right, we end up with countries like Venezuela and Russia, Canada and Norway, which have very little of their economy is based on oil, and they are much more democratic than the oil-based economies.
Professor,
Yeah.
where do you think the US would stand on that chart?
Yeah, I asked my son that question, and he said it would be somewhere between Venezuela and Canada.
That would make sense.
Yeah, I think it does make sense. I don't know why that point is left off the chart, but that's what he said. Any other questions? Okay. So according to my son, solutions for the political problems, reduce energy consumption. That's not feasible. Sign treaties. That's not feasible. I mean, it's feasible to sign treaties, but there's no way to enforce them. The third point, develop renewable energy sources, is something that we can do and are doing. But it's hard because the industries behind non-renewable energy, fossil fuels, are very powerful politically. So here you have a chart of political giving. These would be like political action committees, PACs, from 2000 to 2012. The gray bars are political giving by the oil and gas industry. The red bars are the renewable energy industry. So this would be solar and wind power industries primarily. So it's almost insignificant compared to the contributions of oil and gas. And on the right, we have federal lobbying. So lobbying groups, how much money lobbying groups for oil and gas spend as opposed to lobbying for renewable energy. Again, it's not even close. Oil and gas has much more money, much more lobbying, much more influence than the renewable energy. And that is why we continue, the US government continues to subsidize fossil fuels. So this is the amount of money, I don't remember which year this is, but recently, amount of money as a subsidy. So this is to help the fossil fuel industry make money, as opposed to corn ethanol. And corn ethanol isn't even a good solution because you burn it. As opposed to renewables and carbon capture, the subsidies for these industries is, again, almost insignificant. This is, the point here is that the biggest consumers of fossil fuels consume more than they produce. So that includes China, the US, all the major countries of the world consume more fossil fuel than they produce, except for Russia and Canada. So the most the countries that produce more than they consume are the oil-rich countries in the Middle East. Okay, I think, yeah, so this is the last point I wanted to make, that global warming is truly a threat to life on the planet. So the projection facing extinction within the next 30 years are 30% of freshwater species, 40% of amphibians, 84% of large mammals, 30% of reef building corals, 30% of oak trees, and 60% of all wildlife has been lost in the last 50 years. These, of course, are all estimates. And so these numbers are based on global warming, but there are also other causes, such as overhunting, overfishing, and overharvesting for food, destruction of natural habitats, primarily forests. If you just consider what's going on in the Amazon, which is the biggest carbon sink on the planet, it's being destroyed at a fantastic rate right now. Pollution and population growth. There are simply too many humans for the capacity of the planet, and the population is projected to continue to rise, a 25% increase between now and 2050. And I have here at the bottom, there is hope. Politically, I don't think there is much hope. Economically, I'm much more hopeful. This is where I think if we're going to have any effect on the rate of global warming, it's going to come through the technology for development of alternatives to fossil fuels. Okay, class period is not quite up yet, but that's all I want to say about climate. Are
I
there
have a
any-
question.
Yeah.
Well, it's more of like a discussion point maybe, but from my understanding, I know we contribute a lot to global warming with greenhouse gases and our technology and fossil fuels, everything you've been over. But I was also watching a documentary where they drill into the ice cores in the Antarctic, and they can basically have a map of the temperature of the planet. And from my understanding, our planet also goes through cycles of extreme heat and coldness as well. So is this something that's not exactly causing climate change? It's really just something that's speeding up the already natural process that's happening?
Yeah, you make a very good point. And that is these changes in climate are not new, they're not unusual in terms of the history of the planet. What is new is speed, the speed with which they're happening. So when they happen slowly over long periods of time, hundreds of thousands or millions of years, life forms have time to adapt to them through natural selection and evolution. But when these changes happen quickly, in a matter of tens of decades, it's too fast for populations to adapt to, and so they go extinct. So even though, as we talked last time, extinction is a necessary part of evolution, if the environment changes too fast, then extinction happens faster than the introduction of new species. And that's what's happening now.
That makes sense, because you can't necessarily evolve. Like you can evolve over that many years because it's like millions and millions of years, but how we're doing it's really like speeding it up to the point where it's drastically increasing the water levels.
Yeah. So what was I going to say here? I've forgotten the point I was going to make, but anyway, I want to reinforce what you've just been saying, that it's not that climate doesn't change over time, it's that humans are causing it to change way too fast.
Yeah.
Okay, anything else? If not, let's end the class and get in your questions or topics you'd like to discuss by Saturday. And we'll have a discussion on Monday, the topics that are of concern to you. And then next Wednesday will be test 3.
Awesome. You have a great rest of your day.
Okay. Take care, everybody.
Bye, everyone. Thank you,
Thank you, Professor.
Professor.
Okay, was there a question? It's not, okay. Well, goodbye, everybody, and I'll see you on Monday.
See you Monday. Bye.
Okay, bye.